Today we take our 3 by 100 cubic meter water tanks to the next level. We'll connect them with a proper inlet and outlet manifold and design a pump house to make the system fully operational. Here I'm creating a DN100 outlet manifold for all 3 tanks. Notice I elevate the pipe. This allows better valve positioning and avoids uncomfortable operation during maintenance. As you can see, AutoCAD Auto Routing has its own creative ideas when it comes to routing. Let's fix that. I raised the entire manifold to create enough space for valve installation on the middle tank. I could have kept it at nozzle level, but then there wouldn't be enough room for the valve. The same applies to the inlet manifold. I lowered it slightly so the valves are easier to reach and operate. This way, the layout stays clean and tidy. Imagine if the manifold was at the same level as the nozzles. You would need a maintenance platform on top, and the operator would have to climb up every time to operate the valves. Now, I'm connecting the middle tank to the manifold. My advice is to place a worker 3D model into your design, so you can quickly check whether all elements are easily reachable. Make sure the model is properly scaled. For example, mine represents a 1.9 meter tall person. It's also helpful to use a model with one hand raised, as it gives a better sense of maximum reach. I also noticed that the ladder isn't in a very comfortable position. It's too close to the manifold. I'll rotate it slightly later to improve access. For shut-off, we will use butterfly valves. I am considering either lug or wafer type, since they are compact, commonly used in water systems, and relatively inexpensive. For this model, we will use a simple valve from the AutoCAD palette. In some cases, butterfly valves can be placed directly on the nozzles. This time, I am positioning them a little farther away so that all 3 valves are aligned in one straight line. The valves are now in place, so let's route the piping outside the tank farm. I'm routing both lines next to each other, which will make it easier to add supports to the pipes. Routing one line above the other is also a commonly used method. It helps save space, especially in tight areas, and keeps the layout more organized. This arrangement can also simplify pipe support design, as both lines can share the same support structure. However, you need to consider accessibility for maintenance and ensure there is enough clearance between the lines. Here I am planning to create a pump station for our tanks, maybe not a full pump house, but at least a concrete floor slab to support the pumps. There will be 4 pumps in total, 2 for filling the tanks and 2 for emptying them. In each line, 1 pump will operate as the duty pump, while the second will remain as a standby reserve. I created 2 solids and then used the subtract command to form containment walls, a spill containment pit around the pumps. Containment barriers are needed whenever there is a risk of liquid leakage that could harm people, equipment, or the environment. They are especially important when storing hazardous, flammable, or chemically aggressive liquids, where even a small spill can cause serious damage. In many standards and real projects, the containment volume is designed to hold at least the full volume of the largest tank, ensuring that in case of failure, the liquid is safely retained within the area. Even for less dangerous fluids like water, containment can still be useful to control flooding, protect nearby equipment, and keep the site clean and organized. As the containment barrier is now complete, I'm adding 4 same-size blocks to place the pumps. Pumps can be installed either on metal frames or on concrete foundations. This time, I'm choosing concrete foundations since the containment pit is also made of concrete, so there's no need to introduce a different structure. It would be more optimized to first place the pumps and route the piping to them, because then we could clearly see how large the concrete area really needs to be. Right now, I decided to use a 6 by 6 meter square, but I am not sure yet whether it will be enough. For me, it is easier to model when I am not drawing pipes in empty space, but instead using some kind of structural frame or foundation as a reference. Because otherwise, I might have to redraw the containment pit several times later. Here I'm placing a simple centrifugal pump from the AutoCAD library, slightly scaled down to fit my foundation. Since we have both DN100 and DN32 pipes, we need to make sure not to mix the suction and discharge lines. The DN100 pipe is for tank emptying, so it will be connected to the pump suction side. The suction nozzle will be one size smaller, while the discharge line will be DN80 with a DN65 nozzle. The DN32 pipe is for tank filling, so it will be connected to the pump discharge side. In this case, the discharge nozzle will be DN25, while the suction line will be DN40 with a DN32 nozzle. So, these two pumps take water from the tanks through the manifold and pump it outside. Now, let's connect the line to these two pumps. I'll speed up this part of the modeling, because even a short distance like this requires a lot of drawing, adjusting, and redrawing. Almost 7 minutes modeling compressed into just 40 seconds. And this is just a simple suction line, without any additional components like valves, drains, or supports. For the remaining parts, I'll cut the process and just show the final result. Let's tidy up the discharge nozzles and create the discharge line leading outside. It's the same situation with the other two pumps, so let's cut this part and move faster. I connected the discharge lines to the tanks and routed the suction line out of the pump house. Now I'll add isolating valves to the lines and later install check valves on the discharge lines. I don't see a check valve in the tool palette, so I'll take one from the custom parts palette, a small swing check valve. I tried to select the properties quickly, so the valve appearance looks a bit weird. And that's it for this part of the project. The tank farm, manifolds, and pump setup are coming together nicely. If you found this useful, don't forget to subscribe and stay tuned for the next steps, where we'll keep improving and detailing the model.